So let me start off by giving a bit of context to the comments that I'm going to make. So CSP install capacity over the last 10 odd years, 11 years, has grown from pretty much nothing to just around 6 gigawatts. Not necessarily by design, but we have ended up becoming a developer today with over 25% of that capacity either already installed or in construction. The market, a few of the countries in which we are operating in, has allowed us to participate in this way. So, so we are present with CSP in Morocco, in South Africa, and now we have got a fairly large plant in construction in Dubai. So I'm going to be giving you comments and some experiences with that experience that we have built up over the last decade. So across the fleet that is already operating, we have already generated 3,500 gigawatts per hour of energy. Pretty much the fleet is operating better than expected. So at the time when we develop these projects, we model a base case. Generally, the plants that are in operation are performing better. Some of this is due to better resources, but some of it is also due to the optimization that we've been able to make, tweaks we've been able to make as we have started to operate the plant and get experienced. Buckport, the plant in South Africa, has demonstrated 24 hours of continuous generation with a capacity factor of 95%. I think you've already heard from my friend Tariq from Mazen, DAY1 is very efficiently operating with 3 hours of storage. It's supplying in the evening peak. DAY2, the project that has got 7 hours of storage, has already generated in the first year 635 gigawatt hours. DAY3, in the first 6 months of operation, we were able to generate 200 gigawatt hours. That's a tower project. Absolutely, we have had forced unavailability issues, but we've been working through them. Some of them have been pretty challenging, but by and large, but one thing that really makes us very confident is that not a single issue has been to do with the technology. All has been addressed. Valuable lessons have been learned, and obviously these lessons are going into the new projects that we are developing. DAY1 project has got all of this integrated into it. So there is enough evidence to show that CSP portfolio will perform better than expected through operational life. So we're really satisfied from that point of view. From the financing perspective, I also wanted to highlight that, look, we've been able to get limited recourse project financing done now on 2 fairly large CSP projects. The Dubai project, in fact, the largest renewable energy project underway in the world, was done entirely with limited recourse finance, and it's already in construction. The Redstone project, the financing has been done. It's all the documents signed, financial close achieved. We're waiting for Eskom to clear one item on the effectively adjust the PCOD date, and that will go into construction. The lack of track record, especially in molten salt towers, is of course a concern. But as I say, both these projects have got towers in them, and we've been able to achieve the financing required. Parabolic trough is the mature technology, no question, and we do not foresee any issues with financing that, whatever the scale we choose to do it at. And of course, as we continue to generate more energy, learn more lessons, and from that point of view, some of the failures are helpful. It allows us, and the speed with which we are able to recover, it gives confidence to the financiers. I think it's worth sort of stopping a moment to talk about where the technology is headed. The real value is in creating, is in the storage. It is an economic storage today in the absence of the electron battery long-term storage. So the real benefit is by integrating CSP together with photovoltaic generation. Indeed, as we are doing already in the Dubai project. And as we continue to, as more and more photovoltaic and wind energy penetrates the systems, storage is going to become more and more needed. And definitely in the zone where the resources are available, that particular belt across the world, CSP is proving to be the viable storage solution that can get more and more integrated with the greater penetration. Jordan is a fantastic candidate to be looking at CSP now, because they've already started to get some significant wind and PV penetration into their system. But as we develop more, we're also getting a lot of other ideas in terms of other viable operation. Heat for process application, no question, is something that has already been applied in Oman. Process heat is being used for enhanced oil recovery, for production of steam. There is tomatoes being grown with process heat generated from, or heat generated by the solar field. So that's definitely an area. Solar desalination is an obvious one. And I think what is yet more exciting to come is hydrogen, generation of hydrogen using renewable energy. If we are able to use the electrolysis process continuously, it will continue to bring the cost of it down. And for us to do that, the best way is to integrate PV, CSP, and wind, so that we are able to provide continuous supply and utilize the electrolyzers. So there's a lot of opportunity in front of us, but what is going to drive all of this is continuous focus on cost. You've already seen the cost coming down quite phenomenally. We are at about a 7 cent per kilowatt hour sort of level, 6.5 probably. We see a path to continue to reduce this to below 5. And the reductions will come from more deployments in the countries that are already using CSP. Definitely the entry of China and a clear visible pipeline will allow more participants to come into the sector, which in turn will bring more definitely innovation in addition to more competitive tension. And the bigger the CSP plants, we can reduce all the fixed costs, the power block, the balancer plant costs, which would also help to drive costs down, as we saw in the case of the DAY1 project. And as we go forward, more optimization, more and innovation in the receiver designs, the solar. And just really scratch the surface of utilization of big data, the advanced analytics and artificial intelligence. And I think there is opportunity there, not only on the climate modeling and the prediction side of it, but also in how we efficiently operate the plant, how we optimize dispatch. And of course, as I've already pointed out, hybridization. Just finally, a couple of comments on, I mean, if I were, in terms of lessons, there are sort of two things in project planning that will make a huge impact, and two things in construction that makes a huge impact. There is a whole lot of other things that, of course, one needs to be careful about. But the two big things that I think one needs to focus on is obviously the first one, resource, really modeling the resource and identifying the resource upfront. The data around modeling that the solar resource, particularly with climate change looming over the horizon, and it's really happening in front of us, this is going to become more challenging, and that's something that we need to continue to work better at and watch out. And we talk about the solar resource all the time, but we have also got to look at the environmental resource, environment around the solar field, particularly wind, because wind will have an influence not only on designing for wind loads, but also on operability of the solar field. One of the things that we are noticing is that if we're not very careful and we have not planned for it properly, we will end up with a lot of downtime due to increasing wind speeds. So those are two things that I'd highlight. On the construction side, two things to highlight. Look, this at the end of the day is as much a power plant as a chemical plant. Molten salt is a very corrosive material. High temperatures, high pressures, a lot of pipe work, a lot of moving parts. It's fairly unforgiving. So quality of manufacture of components, fabrication, quality of construction, pretty critical. All the issues we have had, and we will continue to have, I dare say, is to do with that quality. And it's not beyond the wit of humankind to deal with this in a proper way from day one. It just requires more rigor and more care upfront. And that really is the biggest issue that we see in terms of reliability. But it is a stable, reliable, operable technology. Thank you.
Thank you very much, Paddy. That was great. You always have this ability, you know, to be able to go into the general and the very specific. So thank you very much. Can I ask you to stop sharing, please? We're gonna get to the questions thereafter.
Stop share.
At the top.
Yes. Yeah, done.
And I'm just gonna go to the next presentation and then next, okay? And then we'll take it from there. So I'd like to ask Jayesh now to share your screen, please. And make sure you unmute yourself as well. And then we'll circle back with the questions thereafter. Aqua Power at the moment, I believe, is the company with the most megawatts installed or in construction of CSP. All right, Jayesh, we can see the presentation perfectly. Off you go.
Great, thanks, Ben. Project development best practice. My name is Jayesh De Silva, and I work in business development for Bright Source Energy. I'll quickly do an introduction of Bright Source, and then I'll focus on 5 key items of project development best practice and conclude with some key takeaways. Bright Source was formed in the mid-2000s specifically for CSP tower technology. It is a world leader in that technology, and Bright Source, one of the first projects it did, one of the largest projects, and I think it's still the largest operating tower complex in the world, is Ivanpah in California, which is 3 CSP plants totaling 370 megawatts. And Bright Source did the project development and built the solar field, and it was a $2,200 million project, and it's operating now for 7 years successfully. Ashalem was another project that was that's now operating, and that was commercially project financed, and it's got the world's first fully wireless heliostats operating there. And the one that we are working right now is the Dubai CSP Tower project, and Bright Source is building the solar field together with a joint venture with Shanghai Electric. And to give you a sense of the scale of this project, it'll have the largest solar field in the world. It's got 1.8 square kilometers of reflective area alone, and this CSP Tower project will have 15 hours of storage. That's about 12 times the size of the largest battery in the world, the Hornsdale in South Australia. So CSP is really providing bulk energy storage, and that is what DAY1 is going to achieve. Some best practice experience from projects we've looked at. It's important to say that effective early stage development really has a big impact on success. You need to select a good site. It sounds obvious, but it's still worth reflecting on it. Once you've got a good site with the good solar resource, good infrastructure, including grid, that really helps. But also you should not just rely on satellite data, you should have accurate ground measurements. And you should measure not just the solar resource, but also things like the aerosols in the air, which is called the attenuation. And you should carry out geotech studies and so on. And these sort of things, including permitting, will ensure that you reduce the unknowns up front, which really helps you to speed up the project, reduce costs, reduce risk, and increase the probability of successful projects. And some good examples here from the Middle East, North Africa region are Mazen and Diva, who select the site and do a lot of these initial preparation works to begin with. Another item that's quite important is designing tenders that are flexible for bidders to optimize plant design. CSP has huge potential economies of scale, but it's not a modular sort of technology like wind farms or PV modules where you can gradually increase. You have to design the plant at the outset, and therefore it is important not to put in artificial restrictions on the plant output, which could lead to increasing the unit cost of energy. You may wish to define the hours of dispatch, the hours that you want to operate the plant based on your demand profile, but try not to narrow the limit on the capacity if you want to get the best energy unit costs. Tenders this could be avoided by allowing tenders that are flexible so that the bidders can come back with optimized solutions, and also providing bidders to provide alternative bids, which encourages innovation and optimization further. Another thing is CSP is not just a generation technology, it has storage, and it's a long-term economic asset. It has a much longer lifetime than batteries, which are like around 10 years, or wind or PV, which is 20 to 25 years. This is an asset that will have an economic life of 35 to 40 years. The SEGS plants that Bright Source engineers built in the 80s in California are still operating 35 plus years. So it needs to be reflected in the power purchase agreements. And Dubai is a prime example of this, where they had the Diva project had a 35-year long PPA. It also is incumbent that you take in the other inherent values that CSP brings. It's a dispatchable form of energy, and therefore capacity payments are worth considering. And an example of this is in Chile. There is potential for capacity payments for these sorts of projects. And the ancillary services that these plants can offer also need to be considered when structuring the revenue streams of these projects. It really pays to have a long-term commitment for this technology. Where markets have provided long-term commitment, the price reductions have been phenomenal, and also the localization has been very strong. Sustained project development is one way, or multiple projects like in Dubai can also provide this. It also creates this incentive for the supply chain, the EPC contractors, the local construction companies to really invest on working locally and sharing the knowledge. And an example of this is South Africa, where they had several rounds of CSP projects. And this graph just shows you how the price reductions happened over time compared to the first bid round over time. So by the fifth bid round, it was 43% cheaper than the first bid round. Oops. And here we go. So to conclude, the Effective early stage development really pays off. Select a good site, collect ground data, and you increase the likelihood of success and reduce uncertainty and costs. Provide flexible tenders that help innovation and optimization. Provide a long-term PPA that matches the plant's long economic life. And reward CSPs for the storage and dispatchability with ancillary service for capacity payments and ancillary services that it can offer. And consistent long-term commitment to the industry pays off in terms of better prices and higher localization and high local jobs. In fact, KPMG did a study in South Africa and found that per megawatt installed, CSP generated the most amount of jobs out of all the different technologies they tried out. Thank you, Belen.
Thank you very much, Rajesh. We actually have ESCOM on the line. I saw people from ESCOM here. So, you know, I'm glad that you guys are referring back to South Africa so much. If you can please stop sharing. Yeah. And I'm going to ask the next person, which is Fernando, to share your screen just once. It's at the top of, yeah, perfect. Fernando, just unmute yourself, share your screen. And just to let you know, we're actually super global, you know, in this event. Actually, we have Paddy and Jayesh, they're both in the UK. You know, we're all under house arrest, you know. We have Fernando in Washington, DC, and I think we have Lee. I suppose you're in Beijing or Shanghai. I'm not quite sure. Where are you based?
Yeah, I'm in Hangzhou, nearby to Shanghai.
All right, very close to Shanghai. So as you can see, this is the magic also of the online events, isn't it? That we can get so many people from so many different places, all in the, and it's super early for Fernando, and it's probably very late for Lee, you know, but we're all here, CSP lovers. All right, Fernando.
Okay. Can you see the presentation?
Perfect.
Can you hear me?
Yes, and we can hear you perfectly, so go for it.
Okay, well, thanks everyone for joining today. I'm Fernando Gonzalez. I'm the CEO of the Cerro Dominador project in Chile. Let me see how. Okay, this is where we are. This is where the project is located. This is a world map that you have probably seen many times before. And as you can see, the northern part of Chile, it's one of the best locations in the world for in terms of radiation, and in particular for CSP location. So our plant is about 1,600 meters above sea level. We're in the desert, obviously. And the interesting part is that we're close to consumption centers. We are near a very important mining area in the country. And we're also close to water supply, which is important, even though we are minimizing the use of water. And then we have, the project is built on a 30-year land concession. The land is owned by the state, but we have a concession to use that for 30 years. So a little bit of the description of the project. We have a combination, a hybrid CSP and PV project. The PV plant is 100 megawatt. It has been in operation for about a year and a half now. It has a single axis tracker. And the CSP is 110 megawatts. It's under construction now, and we have a tower of 243 meters. And the most interesting thing is that we have 17 and a half hours of storage on molten salts, which basically allows the CSP plant alone to run 24/7. We also added 12 megawatts of batteries for additional flexibility. And also it's important to mention that we have PPAs, 15-year PPAs. Unfortunately, we don't have the 25, 30 years that Jayesh is mentioned in his presentation, but we have 15 years. And it was interesting that those were awarded in a competitive auction where we competed with other technologies. So it was not an auction just for CSP or for renewals, but we competed with other technologies in 2014, and we won. So this is a picture of the project, a recent picture of the project. This is where we are in terms of construction. We finalized the lifting of the receiver in January. The receiver was built at the bottom of the tower, and it was lifted early January this year. We're over 85% completed in piping at the tower. We have started the process of melting the salts. We're over 80% of the salts already melted, and we expect to finish that in the next 10 days or so. We have the turbine in place, so we're pretty much advanced in the construction of the project. Now, as you know, we are in the northern part of Chile. Chile is a very competitive market. Chile has no fossil fuel in country, so all of that is imported, but it's very rich in renewable resources. So Chile is looking to, as many other countries, to clean their energy matrix. And in one of the scenarios run by the system coordinator, you can see at the right that there's a significant expected expansion of CSP technology particularly because of the price, but also of the flexibility that it adds to the system. So we are very confident that the future in Chile has plenty of opportunities for this technology. And this was one of the questions that we had in the chat before, and we think that it's not only Chile, but other parts in the region, the northern part of Argentina, southern part of Peru, and I think Mexico is also a good place, and other locations are great for CSP. Now, the problem of being the third or fourth presenter is that a lot of the interesting things were already said, but I'm going to try to give a little bit of our view on how things are in Chile. So in particular in Chile, there's a very competitive landscape. This is a market that does not have at this time a particular process to foster renewable energy. So we have to compete with all the technologies. And the concept in Chile is that they are technology agnostic, which we think it's a good one. But I think now that with all the significant increase in variable renewables, I think there's an opportunity to while being technology agnostic, to value the attributes that some of the technologies provide, like flexibility, and recognize the value through other means, like a particular auction for clean, flexible energy, or recognizing the value through additional capacity payments or something like that. But at this time, one of the challenges we have, and I'll cover this in some of the other slides, is we have to be creative. We have to find ways to compete with other technologies, even though we provide other services like flexibility that are not provided by other technologies, but we have to think outside the box and find solutions that work for our clients. And this is just going through to the second point I want to make. Chile, most of the PPAs, at least in the last few years, the big ones, were done through public auctions to supply the distribution companies. There is an auction that was scheduled for this May that has been postponed to November, and that was one of the ways to get PPAs. Again, these are shorter terms, 15-year PPAs. But in the last few months, we have seen a significant appetite and interest to have private PPAs with this type of technology. So we're working very actively on that. And again, as this is a very competitive market, one of the challenges, which is nice, which is we need to be very creative in designing and presenting the value proposition. So some of the clients value the fact that we are providing clean energy, base load power 24/7, which is very nice. But at the end of the day, if we are not there on pricing, it's hard to win the PPA. So there may be a few a little bit of margin for someone to go with this technology, but at the end of the day, we need to provide a solution that is robust, that it's clean and renewable, but it's also in the ballpark in terms of pricing. And then that links into the third one, which is the financing. What we are seeing is, at least in this part of the world, we are seeing we think this is a buyer's market, and I think the clients are interested in these type of PPAs, but they're not. They're more interested in shorter terms, which will then allow us the opportunity to renew that if we perform well. And then in terms of the financing, what we're seeing is that we have to, in a way, aggregate the number of smaller PPAs that can support the financing of a new power plant, and that's what we are doing at this time. But this is a challenge, and it's something that some of the financing institutions are already seeing this trend of having lower PPA, shorter term PPAs with the opportunity to renew, as opposed to longer term PPAs with just one off-takers. We'll see shorter terms with more than one off-taker, which in a way helps diversify and mitigate the risk. And then finally, the last thing we need to do is we need to demonstrate performance, right? So we need to, that's why at least in what we are doing, it's critical that that our Cerro Dominador project and the other projects in the world show performance. There have been projects for many years that have had very good performance. So we need to keep showing good performance and explain that this is and show with numbers that this is a real solution in terms of clean energy and flexible. And in terms of next steps, as some of you may know, we are, in addition to working to finalize our Cerro Dominador project, we have acquired the Delicana project, and we are looking at a few other development opportunities, combining, as Paddy was mentioning on his first presentation, just combining CSP with PV, with our technologies that can provide a very competitive offer. So we are very active on that. We are interested in looking at new opportunities. We have the capital and the interest. We just want and need to be sure that the market conditions are there, that the PPAs are available. We're open for business, so we're interested in meeting with any potential client and anyone interested in this technology. And we expect that, I think one of the conditions that we need to move forward is that the rules of the game are respected and are sustained over a long time, because these are very big infrastructure projects that require a significant upfront capital commitment. But we're happy and we are willing to keep investing in the region. So that's a little bit of my presentation. I'm happy to answer any question there. I wanted to be brief, so to leave time for other presenters.
Thank you very much, Fernando. Thank you very much. Lee, why don't you share your screen and unmute yourself, preparing for your presentation. I like your creative financing. I'm really looking forward to asking you more questions about that, because oftentimes that's the thing, isn't it? We need to figure out ways to make this work, because kind of the boxes, the way things have been working don't necessarily fit on renewable energy projects, and particularly the type of renewable energy projects we're doing here. So we need to get creative. I love to hear that. You guys, I'm just going to ask you, whilst I'm here, why don't you reply by text to the questions that are there if you like, because we have a few and we're not going to be able to get to most of them. So if you like, you can go answering those. Okay, Lee, perfectly. We see your screen.
Okay.
Ready.
Thank you, everybody. Thank you to invite me for this very excellent conference in this very challenging time. So we hope that everybody is fine now. So, okay, and today the topic is the best practice of CSP. So we will share our experience in one project which we did in China. It is a 50 megawatt project. And before that, I just want to brief our company background to all of you. So Subconsolar was founded in 2010, and we are dedicated in the CSP tower technology and engineering and project development. So we hope to be the technology provider, the equipment integration, especially in the heliostat field and receiver system, and also engineering of the whole project. Of course, we also developer, investor, and constructor and operate the tower CSP plant. Like the project I'm going to show you, we are also the developer and the investor of the project. So after 10 years operation of this company, we have owned the complete technology of CSP tower, including more than 200 patents. So this is the main reference which we have in the CSP tower industry. So the first one project is a 10 megawatt project. We call it DAY1 10 megawatt. It is a 10 megawatt project and with about 3 years operation. And the second one is a 50 megawatt project located in the same place. It has been commissioned for more than 1 year, but for the commercial operation, it started from the September of last year. So it means it has been in commercial operation for 6 months. So the third one is the Gonghe 50 megawatt project. And it has been synchronized last year, and we are doing the performance test. And hopefully it will be in commercial operation in the next 3 to 4 months. And the last one is the Minos 50 megawatt project. It is located in Crete Island of Greece. This project, we are the member of the consortium of EPC with CGGC China, and we are technology provider and the core equipment supply for this project. And now this project is in the final stage of the financial closing. So then, before I give you the detailed information about this project, we would like to share some pictures of the project in operation. And this is the heliostat and the receiver. And this is the from top view. You can see the receiver, the turbine house, the molten salt tank, and all the facilities in the factory. Now, this is the brief information of the project. The project is located in DAY1, Qinghai. It's about 3,017 meters above the sea. So maybe it is the highest CSP plant in the world. The DNI is approximately around 2,000 kilowatt hours per square meter per year. The capacity is 50 megawatt. We have 7 hours storage with molten salt, and totally about 540,000 square meters heliostat, and more than 10,000 tons of molten salt. And the electricity production per year is about 146 gigawatt hours. So we started construction from March of 2017, and we got synchronized in end of 2018. So totally it's 21 months, but we got 3 months downtime due to the low temperature in the summer in such a kind of high altitude place. So the total real construction time is 18 months only. So I think it's a new record of construction speed for the tower CSP project in the world. So, and also we started the commercial operation from end of September. So this is the performance test we did during the commissioning period. So the capacity we designed at 50 megawatt, and during the operation is reached to 52.1 megawatt maximum. And the minimum load is designed for 15 megawatt, but in the real operation, it can reach to 7.5 megawatt operation for the long-term operation. So this shows the flexibility of CSP technology. And storage is 7 hours, and really almost the same, a little bit more than 7 hours. And the molten salt to temperature can reach to 566 centigrade. And the efficiency from solar to thermal in the design point is 52%. In the real operation, it can reach to 56.6%. And the efficiency from solar to electricity, this is most important. It's designed as 22%, but in real operation, it can reach to maximum 24.2%. It's almost 10% higher than design value. So you can see almost all the important performance index reach or exceed the design value. So let's just review the performance in the commercial operation in the past 6 months. Totally, it generated about 75 gigawatt hour electricity in the first 6 months of the commercial year, commercial operation year, which equals to about 97% of the performance model value. So you can look at that from the first month after commercial operation in October last year is 85%. Then the second month we reached to 93%. Then the third month 97%. So then in the later 3 months, every month we reached to more than 100%. So I think this is a very exciting information for this industry, because as we know, for most of the CSP tower projects in the world, normally it will take about 3 to 5 years to reach the 100% of the performance. So we did it. We hope to did it to reach to 100% of the whole year performance in the first year. So this is our expectation. This slide shows we have about we have the longest continuous operation for this project is almost 300 hours. And normally in the daytime we keep the full load, and then in the night we reduce the load to about 10 megawatt, 15 megawatt, depends on the sunshine. So during that period we don't have any stop every day. And the total electricity generated is about 3.4 gigawatt hour, and the total performance model, total performance reached to more than 105% of the performance model. And this is financial forecasting. So this project developed by Subcon Solar, and we are one of the shareholders of this project. And the total capex is about $115 million. We got the lender is CDB, China Development Bank, and they offered 80% of the capex. So the equity is 20%. The interest rate is 4.9%. So it is totally is a pure commercial financing project. And we have the feed-in tariff, it's around 16 cents US dollar per kilowatt hour. So according to all this performance, we can reach to the equity IRR is around almost 16%. And according to the actual performance we did in the last 6 months, we hope the equity IRR will reach to 17%, even more by the high performance. So we hope it might be the most profitable CSP project in the world. So the payback period is almost 5 years. So now after that, I will just brief you another project, which is it's already commissioned, but we are doing the performance testing. And this is another project called Gonghe 50 megawatt CSP project with 6 hour storage, and project owner is Power China. The EPC is also Power China, and the tower construction is Power China Shanghai branch, and the power block is by Power China Nuclear Construction, and we are the technology provider and the suppliers of the heliostats and the receiver with all the control systems. This is a picture of the project. So we hope after 3-4 months, we can give more good news of this project to all of you. So this is all my presentation. So if you got any questions, you can visit our Twitter or YouTube or send an email to us. So we are happy to communicate with all of you for any collaboration in the future. And thank you.
Thank you very much, Lee. If you can please stop sharing at the top. And thank you very much. And now we have about 10 minutes for questions. So I'm going to take advantage. Thank you very much for answering some of those that keep on coming. You know, we're all doing our best. Lee, can you stop sharing your screen, please? It's at the top of the screen.
Okay.
Oh, perfect. So now we can see you a little bit better. So, okay, I have several questions. I'm going to throw them at you. First, Patty actually was the brave one that said, okay, I think 6.5 is about, you know, what the price of CSP is at. I know that Fernando has a tender coming up very soon, and you know he's preparing the paper. So I want to hear your best numbers, guys. Like you can somehow caveat it, like you know, oh yeah, if it was in this place and that place, that's fine. But I want to hear the numbers, and I want to hear them really the positive numbers, how much we can get. Paddy, you can start. I mean, you said 6.5. You said this is possible now. What about 2 years? What about 5 years?
No, I look. I think. As I said to you when I did the presentation itself, we can see the trajectory. We can see where the costs can continue to be brought down, where the elements are. And so, yes, I'm sorry, we're going to have to continue to caveat, right? So long as you don't sort of start applying super tax, so long as you don't start applying, go and put it in completely the wrong place with a lot of dust, with a lousy resource, you know, so all of that being good, we see CSP getting down to below 5 cents. And I think if we can have reliable, dispatchable energy at below 4.5 to 5 cents, I think we are pretty much not quite done, but getting close to being done. So and I think that's within a reasonable time horizon. We need to see 3 or 4 more projects, but these projects need to be at scale, not 50 megawatts, 100 megawatts, but they need to be the kind of DAY1 scale with long-term PPAs, with freedom to optimize. If you start constraining, you know, I want power only for 2 hours between 1 o'clock in the morning and 3 o'clock in the morning, okay, fine. You'll end up, you got to pay a premium for those specific requests. But if you allow maximum optimization, we see really attractive price reductions coming.
Fernando, I want to hear, because I know you guys have put a tender before for 4.8. You do have exceptional resource down in Chile, but I'm hoping to see better this time around. I'm not going to lie.
Well, just one thing. The proposal was submitted by Solar Reserve, so it wasn't us. And as I mentioned before,
you do have the Ghana now, though, yeah?
Yeah. Chile is a very competitive market. And if I give you the price, I'm going to be opening this to my competitor. So I promise you will be the first one to know once our contracts are awarded. But just in general, we are very optimistic, and the fact that we are actually not only working on the public auction, but having conversations with private actors means that we are definitely in the money on what's going on in the market. So again, I'm very optimistic. I can't wait to show these numbers to the rest of the world. But I cannot do it before getting the PPAs.
Sure.
So I will only be happy, Fernando, if you actually surprise Paddy. That's your job.
I'd be very happy to
not going to
surprise
visit
Paddy. That would be my day.
All right, Yayesh, I'm going with you. Like you're gonna have to like you really gonna have to like push yourself, you know, to give me a number here that surprises me. Go on.
I completely agree with Paddy's comments there, and it's all about scale. CSP has huge potential scale benefits, so you need to really maximize on that. And if you design tenders in an innovative, flexible way, which really harnesses the potential of storage, it's already competitive, and it will continue to be even more competitive. You know, the 60 cents range is feasible.
You can
Okay.
get below that, way below that.
Yeah, 60, but like he's a little bit more conservative. I like your line better, Paddy, personally, but you know. What about you, Lee? How did you see the midterm? Because China has so much to do with these prices coming down. So,
Yeah. China has a lot of chance, and we are doing a lot of projects right now. But unfortunately, in my point of view, in China, never talk about 5 cents or 6 cents, because the solar resource, our solar resource is almost only half of Chile. So, and also the financing. So we don't have very good financing environment. So our interest rate is very much higher for bank. And also we don't have very long-term PPA. That's why there are very few foreign investments have any power plant in China, because we don't have PPA. Yeah, it's all feed-in tariff announced by the government. If you consider all the factors in China in the next 5 to 6 years, I believe that the CSP cost can be reduced to 10 cents US dollar. But if we're talking about in China, it's already competitive enough, because we never consider ourselves CSP as a competitor of PV or wind power. We are not competing with anybody. We are only competing with the conventional fossil power plant. Yeah, because we are clean energy, and we are competitive enough if you consider the value of our storage and base load and dispatchability. So this is my point of view.
okay, you guys, and we don't have a lot of time, but since I have like these bright minds, high level minds, I know most of you before, I just would like to ask a question that I think all of our attendees are thinking now, you know, and it's kind of the obvious one. And, you know, sometimes it's difficult to bring in because there's so much uncertainty. Two things: how is the oil price been on the floor? And how is this COVID crisis going to impact sort of mid and longer term this particular industry, you know, the supply chains? Paddy, I'm going to ask you to start.
Quick answer on COVID. Look, it's very difficult to forecast and predict whether, you know, when we are going to be able to conquer COVID-19, but I'm very confident of human ingenuity and our capacity and resilience. So it's just a matter of time. But once we are in the business of, or the subject we are talking about is electricity, energy, the world is going to become more and more electric. It's going to utilize more and more electricity. So regardless, and just because of COVID-19, we are not going to go back and say it's okay to emit more carbon. So all the issues before COVID-19 are going to be with us as far as electricity is concerned after COVID-19. So I absolutely expect our markets to continue to ramp up, more demand, more need to decarbonize. The big difference will be that there's a huge amount of capital that is now being pulled back by everybody and being constrained. So that capital will become available. We'll be looking for investments. And we provide in this sector stable long-term investments. So I'm very confident post-COVID-19, we will actually see an opportunity for growth and reset and become more re-energized. Sorry for the pun. And so that's on the COVID. That's on COVID. Oil. Look, the bottom line is it's finished. Nobody is going to go back to burning oil for power generation. You can forget about this. Okay, not because even if you give me oil for nothing, there are better uses for oil if you're going to give me oil for nothing. So I am not at all convinced that oil is going to constrain the growth of renewable energy and the need for decarbonization.
I want to put a little bit of Patty in my life because she's always so positive, and I love that long term. And it coming from a Saudi company, I think it's important to also hear these messages.
And even in the Kingdom of Saudi Arabia, they are not reversing any policies. I mean, they're if anything, they're accelerating renewable energy, and I expect to see them accelerating renewable energy deployment even more.
So these are the right messages we want to hear. Fernando, you asked for the turn of questions.
Yeah. I mean, I fully agree with what Patty was saying. And there's one more thing with all these, the issue with the coronavirus. You see a lot of countries closing down. So you cannot. I mean, the commerce is limited, but at the end of the day, you still in some of the countries you still rely on foreign imported fuel, which can be challenging if you have our borders closed. Unfortunately, or fortunately, you cannot close the sun, right? So you'll always have that, and I think that's a geopolitical thing that cannot be minimized, particularly based on what we're seeing with COVID.
Yeah, I mean, there are challenges. The UK has announced several energy companies that there might be blackouts because they come. So there is things still. I don't know, Jayesh, Lee, would you like to add anything?
Yeah, I'd like to answer the two questions in together, really. I mean, if anything, we learned anything from COVID-19 is you need to act soon, and you need to act as in a coordinated fashion. And the next crisis, or the crisis that's already hitting us, is the climate crisis. So just to go back to burning oil for electricity I hope that's not going to be the route for us, because the crisis has demonstrated that you need to act fast and act soon. And CSP is one of those solutions that's cost effective now, and it is continuing to be more cost effective. So let's harness it.
Excellent. Lee, you a different perspective, you are not.
Yeah, because all the people have said all the points which I want to say, but I don't have any new idea. I just want to say that no matter how low the price of the petrol, oil, or even any other fossil fuel, we need clean energy. We need the new energy. We need green.
So, I mean, I think if anything here in the Europe, and we're looking at energy or renewable energy as the engine of growth, of the economy, since it's looking so dire after this. So hopefully, we're hoping that not only they continue the same, but even better, after. So I agree with you guys, but it's also something to consider. So thank you very much for all your help, Fernando, Jayesh, Lee, and Paddy. So now we're going to go into this 5-minute intermittence, and then we'll start with the next session, which is on financing. So don't leave just yet, because it's going to be really interesting.